This video is going to be on compound interest, where compound interest only compounds annually. So that's the big key here, is this annually compounding. As we do the pages after this, you will see that we're going to talk about compound interest when it compounds other times on top of annually. Okay, so let's jump right in here. Compound interest occurs when the interest is calculated on the original amount and any other previous interest. By now, you've seen a couple compounding interest videos, the penny one example, and I believe there was another video in there where the snowballing effect. Both of those are examples of compound interest in action. If we are compounding annually, it means we are adding the previous interest one time per year. Let's look at some of the examples below. On the left-hand side, we have simple interest, which we've already done in the past. On the right, we have compound interest, which is new. So just to go back to what we've done in the past, simple interest, here we have a loan for $1,000 at 10% interest for 3 years. And again, the simple interest formula is, I equals P times R times T. So down below we have 1 year at 10%. Year one, $1,000 at 10% is $100. Year two at 10% is $100. And then year three at 10% is $100. Each time you're just calculating the simple interest formula. So it doesn't change. Year one is $100, year two is $100, year three is $100. So notice each year you only pay the interest on the original $1,000. The amount of interest you pay each year is the same. Now, if you go over and you look at the example to the right, that is compound interest, where you take out a loan for $1,000 at 10% interest for 3 years. Is compounded annually. So year one, $1,000 at 10%, $100. Now that $100 gets added back to the original principal, and that's how you get the $1,100. You add the interest back into the principal, and now you calculate 10% of $1,100. When you put that in your calculator, you get $110. Now you go back and you take that and you bring that down and you calculate 110 plus $1,100 gives you $1,210. That $1,210 gets multiplied by 10%, and you now have an interest of $121. What you notice here is that each year the previous interest is added onto the last amount before interest is calculated. Here you pay different amounts of interest each year. It's always building on itself. Again, the term compound interest. It is important to note that you will pay or earn, because interest is a negative and a positive with compound interest. Compound interest is much often used for credit cards and investments. Savings accounts All right, watch out for loans with compound interest because they pay out very quickly. So when you're talking about borrowing money and it's compound interest, that could be a problem. When you're talking about saving money and it's compound interest, that's what you want. Calculate compound interest, we're going to use the following formula. I'm going to use the exponential growth formula. You're going to need your calculator for this. As you see, we're going to use the parentheses. Okay. Formula here, M still stands for maturity value. All right. So we have M equals P parentheses 1 plus R parentheses raised to the T. All right. So let's start defining what these parts are of the formula. M still means maturity value, which is the total amount to be repaid or the total amount of the account if you're talking about an investment. Principal is still the initial amount. Rate is still given as a percentage. Again, you have to change it to a decimal. We've been doing that all along. And T is time, and it's given in years. So in order to find the amount of interest, we have to subtract the principal from the maturity value. So when you do this formula, you get the total amount of the money that's going to be repaid in the loan or in the investment. So in our previous examples with simple interest, we found the interest and we had to add that back into the principal to get our maturity value. This formula is going to give us our maturity value. So looking for just the interest or just we have to subtract the principal out of our answer with this formula. So let's take a look at an example here. Ron needs $200 to start a snow cone stand for the summer. He borrows money from the bank and charges him 4% compounded interest per year. If Ron takes out a loan for 5 years, how much will he owe? Well, let's start by putting our formula at the top of the page. Okay, now we'll start by identifying pieces of our formula in our paragraph. We have our P, we have our R, and we have our T. So now it's just a matter of putting it together. We have our formula at the top, M equals P parentheses 1 plus R to the T. So M equals 200 parentheses 1 plus, we have to convert that that percent to a decimal, and we have to raise it to a T. So we have to put that into our calculator. And when we do, our calculator should give us an answer of 243.33. So M equals 243.33. Again, that is not the amount of interest. If we wanted to find the amount of interest, we would take the 243.33 and we would subtract $200 from it, and it would tell us that the interest in this case is $43.33. All right, so let's look at it again with Sarah here. Sarah had invested $800 in a savings account that paid 4.2% interest compounded annually. How much was in the account 4 years if she left the money untouched? Let's identify our formula. Let's write our formula. $800. Say 1 plus, convert that 0.042, close to say 4 years. put that in our calculator, you get 943.11 equals 943.11. The maturity value, the total amount that needs to be repaid. So again, you're borrowing $800. When you pay it back after 4 years, you're going to end up paying back $943.11. All right, let's look at number 2 here. A youth group has a yard sale to raise money for a charity. The group earns about $800, but decides the money in the bank. Calculate the money the bank will have if it chooses A. School bank pays simple interest. That word, simple interest, that's what we talked about. We did simple interest in the past. Okay, so simple interest is our formula. I equals P times R times T. So we go back to that formula, all right, but we use numbers up here. So we have our P, we have our R, and we have our T. So I equals 800 times, convert that percent to a decimal, 0.04 times 3. Put that in our calculator, we get $96. Now, we have to understand that this is the interest. So how much money when it's done, we have to take that amount of interest and we have to interest back to the original $800. And you'll see that this this investment will be worth $896 in 3 years using simple. The example below is going to be using interest, which is what we were just talking about in today's notes. And the formula for that is M equals P parentheses 1 R parentheses T. Again, our P is before, so M 800 parentheses 1 plus, convert that to a decimal, raise it to. When we put this in our calculator, we get 927.42. That's M equals 927.42. That is total amount of money that's going to be in the account in 5 years. Again, not the amount of interest. That is the principal with the interest added into it, because that's how this formula works. Question C, if the group needs the money and can only leave it in the bank for 2 years, which one is going to be the better choice? Well, in order to do that, we have to do, again, 2 different ways using both options. So over here we go bank, cool bank. We go hot bank. And we're going to be using formulas for each one. So cool bank was simple interest. So simple interest, 800 times, in this case, 0.04 still, but you only put in for 2 years. You get $64. Remember, $4 has to be added back to the original amount that you put in. So now, after 2 years at Cool Bank, you'll have $864. Hot Bank, we have to go back and use for compound interest, which we see up in the green. Go 800, 1 plus our R is 0.03, and our time here is only 2 years. We put that in our, and we get an answer of 872. What we're getting at here is, even though compound interest in the question above gave us more of a return, when the time is the same for this situation, we actually earn more money in the bank. So you have to actually run the problem to figure out which one's going to give you a better option. You can't just visually see. It's not always going to be one or the other. So you have to actually do the math. Here we go. One more example. All right, you want to put money into an investment. You plan on investing $10,000 and then not depositing or withdrawing any of the money. Money Growers Inc. had an account that earns 3% interest. Account has a full interest. Okay, so just like we just did Cool Bank and Hot Bank, one of these is going to be simple interest, and one of these is going to be compound interest. So let's look at A. All right, we got to do both of these. So we got to do compound and we got to do simple. Compound is Money Growers. And investment are us is simple interest. Okay, so now money, our initial principal is $10,000. All right, 1 plus the percent or the interest rate is going to be 0.03, and it's going to be for 5 years. Okay, and for this, our R and our P is here. Put that into our calculator. It gives us the answer of 1,592.74. Now we want to set up simple interest. Again, that's I equals P times R times T. So our P would be up here as well. 1,000 times our R in this case, 4%, 0.04. Again, the T will also be 5 years. An answer of $2,000. Now, remember, with simple, you're only getting the amount of interest. You have to add amount of interest, which again was 2. You have to add it back to the original principal, which gives you 12,000. Better option here. Okay, so again, in option A, better option, simple interest with investments are, when you do the math, 12,000 higher than the 11,592.74 that you'd get with interest. Now let's take a look at, it says if you plan on withdrawing the money when you retire, let's say years after you open the account. So let's say this is going to grow for 30 years. It's a smarter choice. Again, we'll go with money first, which is the compound. Okay. And again, still starting out with the same 10,000 as the principal. The interest rate is the same, 1 plus 0.03. The only difference here is we're going up to 30. 30 is our T. When you put that in the calculator, you get 24,272.6. Now investment. Simple. A principal of 10,000 times 0.04 times T again. Our T stays there. You get $1,000. Again, that's the interest only. Take $1,000, add principal, and you'll see that you only get 22,000. So which is the better option here? Money growers. So when it's all said and done, up here is your better option. Down here is a better option. Hopefully you see why. Okay.